enable the recording and share the screen. So in today's class, let's talk about the conditional executions. So which is a very commonly used, I would say, a method to realize the conditional running of certain piece of code. And I will show you how it look like. So basically, the if statement is the most commonly used conditional steps. So for example, if you have a variable x and it is assigned to be 5, and then you have the first condition to check whether f is smaller than 10. If that is the case, you have one bunch of code to run. Otherwise, there are other code to run. In this case, it will check if x is smaller than 10 or not. If the answer is yes, so this print function, print smaller function, will be executed. And then it goes to here and check the second condition, which is whether f is bigger than 20. If it is the case, this line of code, print bigger, will be executed. Otherwise, it go to the end of the code and print finish, right? So if we look at the code, it's something like this. If this keyword if gives you the conditions. And in this case, 5 is smaller than 10, so this line of code, print, is print smaller, will be executed. So you have smaller, and this condition, if x is bigger than 20, is not satisfied, right? That's not the case. So this print bigger will not be executed. And then the last line of code, print finish, will be executed anyway. So it turns out the final output will be smaller and finished, right? So that's how the conditional steps work. As you can see here, there are some operator over here, smaller, right? You can see that smaller. Actually, there are more such kind of operator. Here we have a table listing out those commonly used operators. Basically, this is the so-called Boolean expression. No, I mean, these are the so-called comparison operator. And the expression using such a operator will be called a Boolean expression, meaning it will give you this statement, true or false. For example, if you have two variables or two numbers, if you put them left and right of this less than operator, basically it will check whether the left one is smaller than the right one or less than the right one. If the answer is yes, it will return a true. If the answer is no, it will return a false. And the if statement, if you use the if, it will check, okay, this Boolean expression gives you true or false. If true, the code under this if statement will be executed. Otherwise, it won't execute that piece of code. All right. So any questions regarding this? Okay. So there are other comparison operators such as this less than or equal to, greater than or equal to, greater or not equal. So I would like to put more words on two of them. First is this equal to. So as you can see, this equal to basically has two equal sign. So in case you are using this equal to, that means it is actually check whether the one on the left is equivalent to the one on right. Yes or no? For example, if you have if statement, if no, I need to erase this. All right. If 5, I think I'd better use a variable instead of pure numbers. So let's see, you have a variable, like let's see a, okay, and you assign a value 5 to a, and then the if statement will check if a equal to 4. So basically, this line of code will check whether a equals to 4 or not. So you have to be very careful to be sure to put 2 equal sign here instead of 1. Otherwise, it will become a value assign statement, and it will bring troubles to the code. All right. So that's the equal to operator. Another one is this not equal. So it's the opposite of the equal. So for example, if we still have a, and we assign 5 to a, and this time we check whether a is not equal to 4. So in this case, a is 5. So a is not equal to 4. So this will return true. So that means, okay, this condition is satisfied, and the next step will run the code under this if. So that's this not equal operator. So you need to keep in mind these operators, and these are very useful for these forming a conditional steps. Any other questions regarding this? Okay, good. Let's move on. So we can see more examples, right? Basically, if you write something like this, that means if this condition is satisfied, then this line of code will be executed, and the output will be this one, right? So if x equals to 5 is equal to 5, and if that's the case, this print function will be executed, and you will have equals 5 printed. Similarly, this line will be executed when x is greater than 4, and this line is executed if x is greater or equal to 5, and if x is smaller or equal to 5, this one is executed. And if x is not equal to 5, this will be executed. And again, on the right-hand side, these ones are the output. All right. So I will give you a chance to practice these comparison operators in the next lab sessions, and you will be asked to complete little tasks using these operators and the if statement. So there are different variations for the if statement or the conditional executions, right? We have talk about the if statement, and basically only if the condition listed here is satisfied, the code under this if statement will be executed. And otherwise, it will do nothing, right? So that's the so-called one-way decision. So why there's a one, so you might ask, okay, there's a one-way decision. If there's some multi-way decision or two-way decision, yes, the answer is yes. So that's another very important variation for the if statement, and I will introduce them later. But here, you need to understand, basically, only if this condition is satisfied, this code under this condition will be executed. All right, so if we look at the code from here, from here to here, you can see the sequence of the execution of all the code, right? So also similarly here, if you check the x and see whether x equals to is equal to 6, only if x equals to 6, you will have these codes executed. So it's a sequential execution of all the code. The only thing you need to, the only difference is you need to check if the condition is satisfied or not. If yes, you will execute this code. Okay, so that's the one-way decision. That's simple, right? And you might already notice that, yeah, there are always indentations. If you look at here, see, and here. You will see the code. If the code you want to run when the condition is satisfied, there's always a indentation in front of this code. So actually that's a necessary indentation syntax for Python. If you do not have this, Python will be confused and it won't know, okay, you actually want to set up a conditional steps. So the indentation is very important. Basically, you want to increase the indent after an if statement or a for statement after this symbol, okay? And basically, if you want to execute more code under the if or for, you need to maintain the indent. So that will be affected by the if or for keywords. So when the code in the if and for has been completed, you need to reduce the indent back such that it tells Python, okay, that's the end of if and for, and you need to do something else. Okay, if there are blank lines, it doesn't matter. They will be ignored and it will not affect the indentation. But to be honest, sometimes you need some blank lines to kind of divide your code to more meaningful blocks. Of course, you can also add some comments. So you remember how to add comments? How to start a comment? Any idea?
Use
a hashtag.
Hashtag, exactly. Yeah, hashtag. Basically, you add a hashtag and add your comment over here. Yeah, exactly. So basically, the comment and also the blank line can make your code more readable, right? The comments will give some hint of the code, and blank lines will separate the code to different blocks. Usually, one block will be related to one function or one task. All right, these are the some I would say a very useful information, but the indentation is the necessary steps. You have to follow them, otherwise there will be some error appear. All right, so keep it in mind. Oh, more words, a little more words on this. In other language like C language or C++, this indentation is not that important because there's always this bracket. So anything inside if or for, you could just put them to this bracket. That means even the indentation is totally mass. That's also fine. And also there's a this sign over there. After one line, let's see if you have one line of code and another line of code, you can use this this sign over here, and that gives you it gives you the division of one line. So in C and C++, this indentation is not a necessary syntax, but in Python you have to have this because Python have first no such bracket and also no this. All right, keep it in mind. So if we look at the code, and also if you check the previous examples I gave you, it all follows this rule. See, you have one variable and you assign a value, and also here you have set up a condition, and everything you want to be run, if this condition is satisfied, will have an increased indentation here. See. And after you finish this condition, then the indentation become the original one, right? It is true for the if statement, also for this for statement. In this case, the for when you start a for loop, basically you need to increase the indentation, and if there's something like another condition which is inside this for loop, is nested, you will have a further increased indentation. So this print actually is under this if, but the whole thing, the whole whole conditional step is inside this for loop, right? So by looking at the indentation, you can easily tell their hierarchies, their relationship. And again, and also this print is inside the for loop. But this one, actually you have, it's outside of the for loop. So that is very important. It gives you not only the information of this hierarchy information, but also that's a requirement from the Python compiler. All right, so any questions?
Are you basically just saying if
Like if it's indented, then it has to do with the line before it, etc. And then you're kind of wrapping things up and making like one single block. And then once you start like a new line with no indentation, it's saying this is independent from the previous,
Yeah,
block.
basically, yeah, you are right. Basically seeing, okay, this one and this one, this line and this line, they have the same indentation. It means, okay, they are at the same level, this one. But this one, okay, oh, that means it's inside this if. And again, this one, oh, it's these three are at the same level. And this one, okay, it's outside of the for loop. So basically, that's how you tell the relationship between them.
Okay.
Yep.
Got it.
Yeah. So I think that's one thing you have to keep in mind when you write your own code, and after some practice, you will be familiar with this requirement, and it's I mean, trust me, it's more convenient. Because right now you are only dealing with like 10 lines, 12 lines, 15 lines. But think about you have 100 lines or 70, 80 lines. And they're nested if for loop. If you mess it up, it's really hard to find the hierarchy, the relationship. So keep this, and that's very important, and that's also the requirement from the Python. All right, let's move on. Yeah, here basically shows you the different, basically give you the idea of the begin and end blocks as these blocks are circled, right? So basically this means one block, and everything here begins a if condition, and these ones are the one, these code are executed if this condition is satisfied, right? And for example, again, if you have this for loop and this green, everything inside this green rectangle actually is another conditional step, and this line is the code under this if statement. But the whole thing, all these are under this for loop, right? So this is a so-called nested or a hierarchical relationship. So another type of conditional steps are the nested decisions. So meaning you have multiple conditions and they're nested, right? Just from this name. So if we look at a case, the x is assigned to be 42, and the first step is check whether x is bigger than 1. Okay, if that's the case, go inside. And the second condition is actually in this inside this first condition. It will further check if x is smaller than 100. So basically, if this one is satisfied, and this line will be executed, and basically this line will be executed only if these two conditions are satisfied. So if we draw a axis of numbers, let's see this is an axis, and for example, this is 0, this is 1, maybe here is 100. All right. So first you check, whether x is bigger than 1. That means you are looking at the regions on the right-hand side from this point, but it's infinite, right? And then you check if x is bigger than 100, and I mean, is smaller than 100. Actually, it gives, if we draw here, that gives you the region which is left-hand side of this number. So only X are numbers in between of this region. Both two conditions are satisfied, and this print this print function, this print line will be executed. Otherwise, it will go to the end of the code. So that is the nested decisions. But as you can see here is only if there are only two conditions, it's not that difficult to look at. But just think about if you have another condition. For example, if let's see, maybe I just want to have a number less than 50. So that's weird. Okay, 50. Right? And it is under this this condition. Then you need to write another if statement, and you can further set up another condition like, okay, maybe X is bigger than 25, and so on and so forth. Then you need to write another if statement under the previous one. So you can have a very long chain of nested decisions, which will make the code not that readable. So a better way is to introduce the else if instead of if, and I will introduce that later. But keep it in mind, for the nested decision, you can convert it to a more readable code by introducing the else if. So as I mentioned, there are two-way decisions, right? So for the two-way decisions, basically you just set up one condition, and in this case, whether X is bigger than 2, and yes, if the case is yes, a bunch of code will be executed. If not, then another block of code will be executed. So this is the two-way decision. No matter, you either do this or that. So that's the two-way decision for the conditional steps. All right. Let's look at some examples. All right. So you can write some code like this. If X is bigger than 2, then print bigger. Otherwise, print smaller, right? So it's basically either this line of code or this line of code will be executed. And it's a binary decision, either this or this, right? For example, X now is assigned to be 4, and just check, okay, whether X is bigger than 2, yes. In this case, yes, then print bigger, right? Otherwise, print not bigger or smaller. Oh, I think it should be smaller. I will correct this. It should be smaller, not big. Okay, come on. And as you can see here, this two-way decision block is represented by these illustration figures like this. Basically, they are equivalent. And you can see clearly how this works, all right? As I mentioned, there are more conditional structures which are necessarily to be checked. For example, multiple ways. So again, a new keyword elif will be, it's called elif. It's not else if. Elif is introduced. So basically, this elif, you can consider it as else if. It's a combination of the two, meaning, okay, that means, okay, the previous condition is not satisfied. Then else, and what else? If a new condition is satisfied, then this line of code will be executed. All right. I think it's a little hard to understand if we just look at this. Again, let's draw a axis of numbers. All right. And let's see, this is 0. And we have 2 here. And we have 10 here. Okay. So the first condition is if x is smaller than 2. Okay, left-hand side of 2. All right, so if that is the case, print small. Otherwise, go to here. Check. Again, if x is smaller than 10, that means, okay, you are looking at here. But x should be bigger or equal to 2. That means you are looking at this region. All right? If that is the case, print medium. If x is smaller than 2, you print smaller. That's small. And this is medium. Okay, and then there's another else. That means x is not bigger, is smaller than 2. Also, this condition is not satisfied. And then what else? That is, you need to print large. That means, okay, you are looking at regions which are larger than 10. So that's in this region, if any number in this region, just print large. So that's how it works. If we look at this illustration, it gives you the same idea. First, check whether x is smaller than 2. Yes, then print smaller. No, check if x is smaller than 10. That means x should bigger and should larger or equal to 2, and check whether x is smaller than 10 or not. If yes, print medium. Otherwise, that means x is larger than 10, larger or equal to 10, then print large. So that's the 3 different cases. So you got it? Any questions to this multiple ways conditions? Okay, so it's easy to understand, right? Basically, that gives you a capability to set up multiple cases instead of just a binary one, either this or not, or other one, or another one. So you could have all different cases, and which could be 3, 4, 10, so on and so forth, right? So let's look at this example. Basically, that's the original one, but that will give you some idea if x is a different value, has a different value, what happens. So in this example, if x is 0, that means when you check this condition, it is satisfied, then print small. And the the rest two line of code will not be executed. It will go directly to here. See, it go directly to the print all done here, and then the code is completed. I mean, the program is completed. So that's the case if the first condition is satisfied. So what if we set x is 5? So basically, it will check. I think the color has something wrong. Basically, this will not be satisfied. So it will go to check. It will go here and check whether x is smaller than 10, because this one is not satisfied. X is bigger than 2, so this print small will not be satisfied. It will not be executed. It will go to here and check whether x is smaller than 10. Yes. So this line will be executed and go to here. So I will correct this. I think the color here is not correct. I will correct the color. And in case we have x equals to 20, okay, it will check this line. Whether x is smaller than 2, no. Okay, then whether it's smaller than 10, still no. That means, okay, only this one is satisfied. That's the case with the first few conditions are excluded, right? And that's the otherwise. So this line of code will be executed and the final line will be executed again, right? So that's the whole process for this multiple way conditional steps. So any questions regarding this? Okay, good. Sometimes there's no else. For example, like this case. That means if these two conditions are not satisfied, nothing will be done. So if, for example, if x is 5, then this one will be executed. But if both the two conditions are not satisfied, then nothing will be done. You can directly go to the last line, and that's it. So so that's the case if you do not set up a else, right? It's possible and it's totally fine. Meaning, well, I don't want to do anything if these two conditions are not satisfied. I only want to do something, either this one or some others are satisfied, because you are not you have more than two. You could have more than two branches, more than two conditions, right? That's a difference for the from the binary, the two-way conditions. So you can even set 5, in this case 6 different conditions, right? And print different and execute different code, like the one showing here. Okay. Another thing I want you to keep in mind is you have to set up these conditions very carefully. Otherwise, that could be some error. In this case, if you read this code, tell me what's the problems. I will give you 30 seconds to look at it and let me know what's your thought. Okay, who has some idea? What's the problem for the code? Okay, let me give you some idea. Okay, basically, the code under the else will never be executed. Why? Let's see what are the conditions. So again, a axis of a number, right? Let's see, here is 0. And let's see, here is 2. Oh, here is 2. All right, so the first condition, x is smaller than 2. So that is the region which is left-hand side of this 2, right? And then we look at the second condition. X is bigger or equal to 2. So that means the region which is right-hand side of this 2. And then we have another else, means, okay, these two are not satisfied. But is there any case these two are not satisfied? Any idea? Will be possible? These two conditions are not satisfied. Any idea?
No, because it covers all numbers.
Yeah, exactly. Basically, any number will either in this region, will be either in this region or this region.
Oh, I was confused for a second because I thought you were asking us to look at which of the two programs. I didn't know you were asking us to look at the individual lines. Yeah, the last line of the first one will never print.
Yeah, but yeah, it's all right. Basically, if you check these line is also fine. Basically, that gives you a, basically this else is these lines of code are not necessary, or these conditions have problems such that you will never run the code. You will under this else. But no matter how, look at the logic and the numbers of the lines. All right. So that's a case I'm talking about. Basically, you have no case this else will be satisfied, and that's the problem for the conditions. So again, look at this block of code. Tell me what's the problem.
The below 10 will never print because if it's below 10, if it's below 2, it's going to print below 2, but if it's anything bigger, it's going to print below 20, so it'll never get to the below 10.
Exactly.
It's out of order, I guess.
Yeah.
Intended it to be that way.
Yeah, exactly. Let me draw the figure. You will see better. So we have 2, we have 10, we have 20 roughly, okay? So the first condition is whether x is smaller than 2. So that means a region like this, right? And the second condition is, okay, if x is smaller than 20, but larger or equal to 2. So it represents this region, right? No problem. Then that means, okay, we covered this case and this case. And this one then another ELIF must be the case which are not covered by the 2. But in this case, it is covered by the previous one. That means the condition is when x is smaller than 2, and at the same time, it is larger than 2, larger or equal to 2, and it is larger or equal to 20, which are conflict. These conditions are conflict to each other, and this line of code will be never satisfied. So that's where the problem is. So basically, you need to check those conditions carefully and make sure there will be some case that the condition could be satisfied. And that's very important. There are many cases you just set up an inappropriate conditions, which lead errors. All right. I think I've mentioned the indentation, so we can just skip. So another very commonly used conditional execution is the try except structure. So this try except structure will help you to avoid the stop of the code of the program. Basically, if the code in the try works, then the except is skipped. And if the code in the try fails, it will jump to the except sections and do something. So let's look at a set of code. So basically we have the code showing here. And we have a variable, and we assign this hello and hello Bob to this string, but we do a very dangerous operation in the second line. So we are using the type conversion function int to convert this string to an integer. But as I mentioned last, I think in the lab session, if this integer is not numeric, this function would fail. So it cannot be executed. And actually, Python just gives this error code and tells you there's something wrong. So if you have a program and you write code like this, then the program will exit without any warning or notification. And that's the problems because some of the code got failed. So to avoid the exit, we could do a try and except operation. So as we have, I think we can skip this. Okay, yeah, we can skip this page. So if we rewrite the previous code and add the try and except like this, so we still do the assignment statement like this and assign hello Bob to this variable, but instead of directly use this int type conversion function, we put it into the try. That means, okay, it will check this one can be executed successfully or not. If that's not the case, means there's a problem, it will go to the except and execute this line. Basically, it gives this variable a preset number, -5, and then go to the other line, the next line. So if this is the case, you assign 1, 2, 3 to this string, and again, execute the try here. Basically, this type conversion will be executed, but this time, this 1, 2, 3 can be successfully converted to an integer. And that means this except will not be executed, it will be skipped. and it turns out it will go to this line and complete the whole block of code. So that's how the try and except work. So what's the benefit? That is, if you have a incorrect input, the code will not exit, will not stop. Still, it will let you handle the errors and make the code keep on running, which is very useful when you are providing a user interactive code, because user could give you something wrong, could give you something inappropriate, and you have to handle all different cases. You cannot assume every input, everything is correct, right? You have to deal with these error cases, and that's one way to deal with it. Just imagine what we had in the lab session. Basically, we use an input function to let the user to input the hours and hourly pay, hourly rate, and compute the overall wage for a person in 1 week, right? So just imagine if someone just type non-numeric character there. For example, someone want to type, okay, 9 hour and each hour like $20, right? If they put 9, 20, that's perfectly fine, right? You can easily convert it to integer and have it computed. But let's see, okay, they put this. Well, it's still, I would say it's still the 9 and 20, but if you use the int function, which is a type conversion function, which will convert a numeric character to an integer, it will fail. Basically, they cannot do this. So if without this try except method here, the program will exit, and that's not what you want. So if you add this on, even user input something like this, the program will not crash. But the only thing is it will not give you the result. But user can try to input the numeric. Of course, you could give some notification to the user saying, okay, please input the numeric. And user realize, okay, I have to put numbers instead of these. And it turns out it gives you the correct result. But that's only the basic level of a program, right? Meaning, no matter how, it won't crash. But nowadays, even the user want to have the result even with this kind of input. So that's a totally different story. So it requires a program to understand user's intention. That's another level. But here we just look at this basic level at the very beginning. All right, understand? Any questions? Okay, good. So if we have this block of code and we have a variable and it is assigned to be this string Bob, right? And then we have this try except setup. Sorry. So first print hello and convert this variable to be a integer and print there. Otherwise, if there's something wrong inside the try, then execute the one under the except. Then that is you set up a number to this variable, and then print down here. Right, that's the whole procedure here. In this case, because this variable is assigned to be Bob, that means this line of code will have trouble. That means it will run this, and it turns out that will not crash the program. So you can have a trial by input this. You open your Jupyter notebook and input this to your Jupyter notebook and have a trial. See what's going on there. Okay, I will let you know. I will let you try by typing this in your Jupyter notebook and have a trial. Let me know the result. All right. Yeah, you can start. So basically, when you write this line of code to the Jupyter notebook and run it, it will ask you to input something. You can of course, if you input some number, there's nothing wrong. But if you intentionally input something which are not numeric character, it will give you, it won't crash, and it will give you the feedback. It will print not a number. So that's the expected output, and you can have a trial yourself. So I'll give you 5 minutes to have a trial, all right? And let me know what you have. So have you all tried? What's the result? What's the output?
My output was nice work every time that I put in a number.
Okay, good. Yeah, just try different inputs. So that gives you the idea, okay, how to make your code more robust. I mean, you can never complain your users, right? I mean, even there are some unpleasant inputs. You have to respond. So that's the idea when you design a code, a program. But that's one way. Try except. So let's. I think that's all the content. Let's summarize today's class. So we have learned the comparison operators, which can be used in the conditional statements. And the indentation is very important for either if or for statement. So there are different conditional steps: one-way decision, two-way decision, nested decision, and multiple-way decision. Use the ELIF. So the last, we tried the try and except methods to compensate for errors. So in the next lab session, let's try to practice covering all these content. Let's write some program which will ask you to use these operators and set up the conditional steps, and also use the try and except method to handle the errors. All right. So I think that's all for today's lecture, and you can if you have any question, just let me know. All right.
All right. Thank you.
Yep. I will stay here until 4:45. If you have questions, you can ask. If you have no question, you can take your time and leave the meeting room.
Professor, I had a question.
Yeah.
It's not necessarily about today's lecture, but I emailed you saying that I couldn't get my thing done until Wednesday just because I had to wait until then to get my new laptop. But now I do have my new laptop, and for whatever reason, I cannot get the program to open, even though it's downloaded.
Oh, really?
So I'm not sure what to do.
Oh, so I think one thing you could do is just email, give me an email, and I will. So you have first of all, you have your program means what you wrote in the Jupyter notebook, right? No.
Yeah, I downloaded the whatchamacallit, the Anaconda.
Okay.
And you know, like one of the first steps once you download it was to open the Anaconda Navigator.
Yeah.
Yeah, when I go to open it, it just tells me that it can't be opened. And that's so I don't know what to do.
So have you finished the complete the installation of Anaconda?
I believed I had.
Oh, that's interesting.
Is there more to the installation than just clicking download? And
oh no, it's not just the installation. It's not just download. You have to install it. So are you using a Mac or
yeah, Mac?
Yeah, I think another thing you need to check is try to download the right file. There are different files for PC, for Mac, for Linux. Try to download the one for Mac system. And I think because I'm not a Mac user, I don't know if there's an installation step for programs on Mac, or just the download is good enough. So let me see, let me think. Yeah, I think definitely. Can you show me your screen if you want?
Yeah, I can do that.
Yeah. Let me. So you are.
Thank you, Professor.
Yeah.
See you next week.
Yeah. See you. Abby. Okay. Now you can share. Yeah. Show me what happened. Oh, I have to stop the sharing. Yeah. Go ahead. I think we can stop the recording. Let me stop the recording.